So hello guys, welcome to our channel GS and Google Earth Engine. So in today's video, we're going to look at how we can calculate and visualize the leaf area index. So it is an one-sided the green leaf area per the unit ground area, and it is a GCM dataset from the JAXA, that is the Japanese Space Agency. So without any delay, let's start. So today, our region of interest will be Brazil. So it is where our great the Amazon forest exists. So let's take it as our region of interest, and let's visualize the leaf area index, one of the products from the JAXA, the Japanese Space Agency. So now let us import our Brazil shapefile. So you can always search FAO, a global administrative unit layer. So here you will find uh, the first level as well as the second level administrative unit, but I want the country boundaries. So you just click on the import here. So you can rename it as FAO, and you also select a point. So it would be geometry, and now I'm gonna filter my region of interest. So I'm creating a variable called region of interest, and I'm filtering down my FAO dataset, which has the country chapel for the entire globe, and I'm filtering it down with the use of the function filter bounds to my geometry. So let's print this down. Let's see how does it filter it down. So we have a feature collection loading in the console. Yeah, we have one element. If you can expand the column, and if you can just expand the feature, we have one feature, and it has a geometry as well as it is its property. So here you can see the admin 0 name is Brazil, and its status and its shape area, what is the year, everything, and its shape length, everything is written in there. So just want the geometry. So now let's add this to our map dot add layer ry, and I want to style it with the color, let's say black for the outline, and so remember it should be a string, and I want my fill color to be transparent. So I'm using the hexa code here. Yeah, so this should be my Brazil. So just click on the run. Let's see how does it add it to the map now. Our layer is loading. Yeah, clearly you can see our region of interest has loaded with the transparent fill color and a black outline. So you can manipulate the width of the polygon if you want. So after all this, let's also center our map to the region of interest with the use of the function map dot center object to region of interest, so that it automatically gets zoomed into a region of interest every time you run the script. So after all this, let's now import our data catalog. So here you can search global GCOM. So you click on the more. So here you will find the various datasets from the GCOM, the Global Change Observation Mission. So today's we're gonna focusing on the leaf area index. So here you will find the version 1, 2, 3. So the versions are usually for the dates. So here you can see it started from 2018 to 2020 is the last version 2, from 2018 to 2021, and if you can see the version 3, it started from 2021 to present. So let's have the present years or the 2024 years leaf area index. So I'm importing the version 3 of the leaf area index. So just click on the import, and you can close this. So here you can find my image collection has been loaded. So if you can just expand it, it has the image collection ID as well as what is the type, and what are the bands involved. We'll look into it. So before that, you can just rename this as GCOM. So just open the dataset. So as I have already told you, the data set available is from 2021, 11/29. That is from November 29 to the present. And the data set provider is this machine, particularly the JAXA machine of Global Change Observation Mission, which is launched in the year of 2018. So if you want for the 2018 year, you can go for the version one of this particular data set. And it has the bands such as leaf area index average. So here you can see this is the sum of the one-sided green leaf area per unit ground, and its values ranges from 0 to 65,000. So we need to scale this value. Always they will provide a code snippet. I will show you in the later, and we don't want this quality flag or the bitmask flag bands is not needed. So if you can just go to the description, so here you can find the latency of this particular dataset is 3 to 4 days. That is there is a 3 to 4 day delay between the data collection as well as when the data is made available to the public. And this is an ongoing dataset. It means it is continuously being updated. And the global change observation mission, this C stands for the climate, is a Japanese observation satellite, and it's a long-term continuous global monitoring satellite for the uh, understand how the earth radiation budget as well as the energy balance as well as the carbon cycle change over the time. For this particular purpose, they have launched this GCOM satellite, and it using the sensor of SGLI. So you don't need to know more about the sensors as well as the uh, how does it work. So you just need to focus on the band which is of our use and what is the scale value. So here you will find the resolution 4 kilometer. So the best available resolution as compared to the Moody's or the ERA5 dataset. So it is better as compared to those. So it's better to use the JAXA dataset for this purpose. So now I have my GCOM image collection which is imported, and I have added my region of interest. I have also styled it to have the outline black color as well as the fill color to be transparent, and my layer is loaded as Brazil. So let's now filter it down to a region of interest. So I'm creating a variable called leaf area index. So my GCOM dataset has been imported, and I'm filtering it down to bounds. So I wanted to filter it down to my region of interest as well as I want to filter it down to my date. So in order to clearly know how does the filtering work, you can just print this LAI, and you can see in the console so how the filtering does work. So now you can see for the globe, it is a global land dataset. So I have just filtered down to my region of interest. So the number of image collections should reduce now. So it's running. So here you find the collection query aborted after accumulating over 5,000 elements. So this is due to the limitation of the Earth engine capacity. It cannot print over 5,000 elements in its console tab. So let's now filter it down to more. So just remember that as for the filter bounds, we have more than 5,000 image collections. So let's again filter down to date to 24. So I'm filtering down to 2024, or else you can filter it down to 2025 January and 2025 January 31st. So now if you click on the run, now our size of the image collection should reduce. Yeah, here you find out after filtering it down over 5,000 image collection, now we have only 60 elements in here. So this is how the filtering works. So here you can find all our image collections are in the January ADAD. So like I have told in the previous section, so this particular machine collects both during the day as well as the night. So everything will have the two bands. We need to filter down the satellite direction as well as we need to filter down the selection of the band also. So we have 60 image collection for the month of January. And now you can also filter the satellite direction. So if you don't know what's the property in here, you can always go to this data set and just pull it down. Here you will find a satellite direction. So the description is that it is a satellite orbit direction, and A stands for the nighttime, and D stands for the daytime. So just paste it down here, and I want a daytime leaf area index, so not the nighttime. So it's particularly not meaningful though. So now if you click on the run, let's see how much our image collection has. So for 1 month, you see we have only 30 elements since it is a daily data set. So now we have to select the band also. So again, you go to our data set, go to bands, and select this leaf area index AVE and paste it in here. So before clicking on the run, here you will find each feature has two bands. So now it will be reduced to one band because we have selected only the leaf area index band. Yeah, we have the 30 elements for the month of January with a single band, and for the satellite direction is the daytime. So now our filtering is done. Now we need to scale the values. So let's create a one more variable called scale LAI, and again go to our data set. So here you will find one button in the top right corner. You just click on that, and if you just scroll it down, here you will find the same tab with the description, bands, image properties, as well as the citations. But you will also find a code editor for the JavaScript snippet, so which has the slope coefficient which has to be multiplied with our dataset. So here you will find we have to multiply with 0.001 in order to have a meaningful interpretation of the values. And we also need the visualization palette for this. So you just copy this visualization, and we will paste it in our code editor. So now for the LAI, I want the mean of this for the month of January. I doesn't want the median, I want the mean, and I need to multiply with 0.001, which is this slope coefficient which has to be multiplied in order to get the meaningful values. So now let's just add it to layer, map.add layer. Our scaled LAI should be added to the map. And for the visualization, we have already imported the visualization parameters for the better visualization, and here you can just rename it as LAI and click on the run. Oh, okay, we didn't clip it for it, so we just need to clip in here. So clip.roi. So okay, clip doesn't work for the image collection, so we need to clip after the median. So here we have, after getting the mean, after multiplying, you just paste it in here, clip to region of interest. Now it should work. Yeah, our two layers are loading. One is our leaf area index, and another one is our Brazil, that is the out line for our region of interest. So you can just expand the and click on the range, stretch to 100%. So here you find the range which values, and one in the blue color have the low leaf area index, and one in the red color as well as the orange near to yellow, everyone have higher leaf area index. So click on the apply, and you can switch to satellite mode. So yeah, so here you will find near to whatever the forest area is there in the Amazon region. Here we have the high leaf area index, which is a good uh, data set at a 4 kilometer resolution. So this is how you can visualize and layer is still loading. Yeah, so clearly you can see how we can visualize and interpret the leaf area index value. So you can just come to the inspector and click anywhere. So here you will find the LAI image value is loading. The leaf area index value is 4. So here if you find it's relatively low, 3.24. So in the blue regions and all, it will be relatively low, near to 0, I think. Yeah, 0.682. So I hope guys you have understood how we can import and visualize and filter down our leaf area index data set. It's a very important data set from the JAXA, uh, the Japanese space agency, and how you can visualize it through Google Earth Engine. So that's it guys for today. If you have any kind of queries or doubts, you can always post it in the comment section, and feel free to ask. So of course I will be providing the code link in the description box. In order to access this, you need to have Google Earth Engine account and a project created. So thank you for watching.